Okay, here we are on functions packet, page 1. Number 1, consider these relations. Classify them as one-to-one, many-to-one, many-to-many, or one-to-many. So let's look at a couple of these definitions about what does that mean, one and many. So, for example, here we have one item in the X group mapped to a single item in the Y group. Okay, so just one item is mapped to one item. So that's one-to-one. If you have many-to-one, then sometimes you have two or more items mapped to one item in the Y group. So two X's mapped to one Y. Okay, so you can imagine what would be one-to-many, for example. One-to-many would be that you have one element in the X group mapped to two or more elements in the Y group. Okay, and many-to-many would be if you have a one-to-many and a many-to-one in the same mapping. So, like for example, you could have I have three elements here, and I have three elements here, and I have this happening, which is many-to-one, and I also have this happening, which is one-to-many. That would be a many-to-many, right? Okay, so let's take a look at these and see if we can figure out which one is which. So first I see 1, 2, 2, 3, and 1, 4, and the notation here is that they're giving us the X element first, and they're giving us the Y element second in an ordered pair. So one thing I do to keep things straight is I'm gonna see if there are any like doubles. So like, do I have one repeated? Yes, I have one repeated here and here. The X equals 2 value maps just to 3. It's not repeated. And then what about for the Y values? Are there any repetitions on the Y? There's 2, 3, and 4. So there are no repetitions on the Y. So that means that it's one-to-many, right? Because basically, if I wrote this out in a mapping, I would have one mapped to 2 and to 4, right? So that would be a one-to-many, right? So I'm going to call this one-to-many. Okay, and then the next one, I'm going to do the same thing. I'm going to classify, or I'm going to check to see if there are any repeats in the X's, 1, 2, 3. No, there's not. See if there are any repeats in the Y, 2, 3, 6. No, there's not. So this would just be, you know, the 1 maps to a single number, the 2 maps to a single number, the 3 maps to a single number, and 2, 3, 6 are not repeated. So there are no yellow highlights here, so that would be a one-to-one mapping. What about the next one? So in this one, I have 1, 2, 3 for the X's, no repetitions there. And I have 1, 1, 1 for the Y's. I do have repetition there. So the Y's are repeated, which means that what that looks like is I have the X side with multiple numbers, and I have the Y side with only one number, and everybody is mapping to the same number. And so that means it's a many-to-one, right? So that's it's really easier to see when you write it out in a mapping, like we have with these ovals here, right? Next one. Any repetitions here? X value is 1, 1, 1. Yeah, so like the X value repeated every single time. The Y value is 1, 2, 3. It never repeats. So if I drew this out, I would have a 1 map in the X mapping to 1, 2, and 3 for the Y. So that means it's a one-to-many, right? Why am I doing this classification? Because eventually I want to use these classifications to figure out if the relation is a function or not, okay? All right, last one. So do I have repetition here for the X's? Yes, I have a repetition in the X's. There's 2 1s. Do I have a repetition in the Y's? Yes, in the Y's I also have a repetition of 1s. So if I drew this out, it would be a many-to-many, because what I have is I have I'm gonna write it out, okay? So I got 1 and 2 in the X's, and I have 1 and 2 in the Y's, and it says 1 maps to 1, 1 maps to 2. I also have 2 maps to 1. Okay, and so do you see how I have for 1, 2 mapping to 1, that's a many to 1. If I have a 1 mapping to 1, 2, that's a 1 to many, so it's a many to many. Okay? All right, let's go to the next one. A function is a relation between two sets in which every element of the first set, input, independent variable, is mapped onto one and only one element of the second set. Okay? So basically what we want here is we do not want repetition of the y values, because if we have repetition of the y values, so if we have a 1 to many, that would be the equivalent of a violation of the vertical line test, or it would be something that would create multiple functions. In the investigation, it would be multiple turtles at the same time for the same value of x, right? Let's look at a few of these examples and see what we're looking for here. But basically, the idea is that if you have many to 1, that's okay to be a function. And if you have 1 to 1, that's okay to be a function. But the other cases, 1 to many or many to many, those are not functions. They're just relations. Okay, everything's a relation, but only the functions have mappings of 1 to 1 or many to 1. But you can't have 1 to many. All right? All right. So let's take a look at the first one. So in the first one, it shows that every single number maps to a distinct number. So that would be a 1 to 1, which means that it can be a function, or it is a function. Okay, and the reason why is because it's 1 to 1. That's the reason. What about B? So in the case of B, do I have repetition? Yes, I have a 1 to 6 and a 1 to 4, so 1 is repeated here. And then I have 2, 3, and 4 all mapping to 2, so there's a repetition there. So this is a many to many. And remember, many to manys are not functions, not a function. Okay? What about the next one? So the next one, I have both -1 and 0 mapping to 0. Okay? So 0 is repeated. -1 to 0 and 0 to 0. The y value 0 is repeated. So basically we have a 1 to many here. Or I'm sorry, a many to 1 here. Okay? A many to 1 because the 0 is 1 and -1 and 0 are many. A many to 1 is okay for functions. So functions can be many to 1. So that's fine. See, if I look over here, many to 1 can be a function. Okay, express the mapping R in the form x maps to something. Okay, let's see. So I'm going to write x goes to, and then I'm going to put a little formula here to show the relationship, a mathematical formula to show how the x value changes to the y value. And I can see a pattern here. Do you see how, like, it's harder to see with the first one, but with the 2, I can see that it goes into the denominator. 3 goes into the denominator. 4 goes into the denominator. If I use my imagination, I can see that if I put 1 in the denominator, I would get 1 over 1, which would be 1. So basically the rule is, if I have the x value, I can put it in the denominator, and that would be the y value. So I'm defining my mapping by saying x maps to 1 over x. Okay, so then it says state whether or not R is a function. So if I look at my mapping, it's all 1 to 1 mappings. So that means it is a function. And then part C, it says write down the image of 2 under R. So the image of 2 is a fancy way of saying the y value. What is the y value that corresponds to the x value of 2? The image of x is actually the y value. So the image of 2 is the y value that corresponds to 2. And in this case, I look to see the x value is 2. The y value that corresponds to it is 1/2. So the answer to C is 1/2. D. The set A is extended to 1, 2, 3, 4, A, and A maps to 3. find the value of A. Okay, so the A set is going to have one more element called A, and they say that A maps to 3, and they want to know what is A. Well, we know that the mapping would be that A would map to 1 over A, so we could say, well, 1 over A is equal to 3, so we could use some algebra here, and we could say that, I'm going to multiply both sides by A so that it's not in the denominator anymore. So that would be 1 equals 3A. And then I'll divide both sides by 3 to isolate the A, and I'll get A equals 1/3. So the value of A is 1/3. Okay? All right. That was a little bit of algebra there. Okay, number 5. Consider the mapping y equals x cubed. Find the output when the input is x equals -1. Okay, so this one is pretty straightforward, and I think I can use the calculator for this. So whenever you have a function, go ahead and put it into y equals x cubed. Okay, and there's a couple ways I could do this, but remember, table is a pretty convenient way of finding it for whole numbers. And so I want to know what the y value is when the x value is -1. I just go to -1, and the y value is -1. And then it says, find the input when x equals -64. And one of the convenient things about the table is, you can just like say, okay, when is the y value -64? And I can see that the trend is the negative values are above, so I'm scrolling up, and look, the x value is -4 when y equals -64. C. Let the set of inputs be -1, 0, 1, 2, 3, 4. Find B, the set of outputs. Oh, well, see, since I put it in the calculator, it's quite easy to do this, right? So I will start looking at the x equals -1 value, and then I will just write down all the y values that correspond to it. So -1 corresponds to -1. 0 corresponds to 0. 1 corresponds to 1. 2 corresponds to 8. 3 corresponds to 27. And 4 corresponds to 64. Okay. And that was the set of outputs B. So I just listed them there. It's nice to put commas in between them. Okay. Part D. State whether or not the mapping y equals x cubed from A to B is a function, giving a reason. Okay. So if I wrote this out as a mapping, I would have these elements in the x, and then for the y's I would have these, right? And if I drew the mappings, they would all be one-to-one mappings, right? I don't have many-to-one, I don't have one-to-many, so this is pretty straightforward. It's just a one-to-one mapping. And so if it's a one-to-one mapping, then it is a function. Okay? And that's the reason it's a one-to-one mapping. And that's it for this page, I think. Yep, that's it for page 1.